Well, hello there. Hello. I can speak, I promise. Hello there, boys and girls, ladies and gentlemen, and wonderful young people. Now, let's use our fantastic and wonderful Dixon Ticonderoga number two to graph this one right here. This is already factored, so that makes life easy. Hopefully. Let's find out. All right. Now, first thing you want to do is you want to find the degree, right? So the degree of this is in factored form already. This might be able to be further factored, but to find the degree, we have to figure out what would be the largest exponent if these were distributed. So x times x squared is x cubed. So this is cubic. That means I gotta sneeze. I hate that. Since it's cubic, degree is odd. It's either going to go down left up right or up left down right. And the reason we know the difference is by the sign of the leading coefficient. This is going to be 1 and 1. That makes a positive 1. So our end behavior is going to look like that. And that means the number of turning points is going to be a maximum of 2. And the number of x-intercepts is a max of 3. Since it's odd, we'll always have 1, at least, for odd degrees. Now, for even degrees, you can have 0 x-intercepts, okay? All right, now, let's see. Let's find our y-intercept. The way you find the y-intercept is you plug in a 0 for x. Oh, man, our pencil's getting a little dull. We need a sharp line, sharp pencil. Let's see if we can fix this magicness. Oh, man, it feels like there's something wrong with my pencil sharpener. What a tragedy. All right, so we're going to plug a 0 in. Let's go ahead and do that here, all right, since we can't just look and see. 0 squared minus 2 times 0 minus 24, right? Um, let's, oh man, let's see. I'm going to try this pencil sharpener again. It's brand new. It can't be broken already. Can it? Oh, that would be a tragedy. Here, let's try one more thing. Oh man, I know you guys love hearing me talk about sharpening a pencil. Look at this thing. Oh, it's a wonderful little pencil sharpener. Let's see. Ah, now we're getting somewhere. I think the lead was broken in the bottom. Okay. Anyway, I apologize. So this is negative 3, right? Now times negative 24. Mm, that's going to be a positive 72, I think. Let's see, that gives us a 12. Carry the 1, 6, 7. Yes, negative times a negative is positive. So our y-intercept is 0, 72. So that's above the x-axis, way above it. Okay. Now, to find the x-intercepts, you take your whole function, you set it equal to 0, you factor it, you take each factor, set each factor equal to 0. You know the drill, right? So a little practice. So there's one factor. This right here is factorable. So look, this right here is factorable. You take the entire equation, set it equal to 0, take each factor, set them equal to 0. So this times this equals 0 or this equals 0. They could both equal 0. So 1 is x equals 3, no problem. This is factorable. X minus 6, x minus 4, right? So x, if we set it up, equals 0, and x plus 4 equals 0. You're going to add 6 to both sides, right? This is what you're doing, is you're using inverse operations. So we have 3 x-intercepts. We have negative 4, 0, 3, 0, 6, 0. All right, so here's what we've got. We've got a degree of 3, so we know it's going down, left, up, right. We have a y-intercept of 72. And we have 3 x-intercepts, negative 4, 3, 6. I know it's going down left, it's going up right. So this, between here and here, it's going up. And the reason I know it's going up is I found all of the x-intercepts. There's a degree of 3. That means there's a maximum of 3 x-intercepts, right? And I found all 3, so there's no extras. That means from here to here, it cannot cross the x-axis again. I found all 3. That's first key fact. Also, between here and here, I know the function has to go through the y-intercept, which is at positive 72, which is above the x-axis. So it can't go down and then back up. That would be way too many x-intercepts. That's nonsense. It doesn't work. We have a degree of 3, and that means our maximum number of x-intercepts is 3. So between here and here, it has to go up. And then, whoa, that's kind of ugly. Oh man, que feo. Ugly right there. Oh, that's a sad story. We're going to move on with it. Now, between here and here, it has to be, the graph has to go below because the maximum number of turning points is 2 for a function with a degree of 3. So I have one turning point here, and that means I can have one more, which will be here. It can't be here. If it was going up like this, that could work, but that would not be a degree of 3. That would have 1, 2, 3, 4 turning points, which means at least a degree of 5. So it has to be like that. Now, if I wanted to make sure that it actually was going down right here, this is, let's say this is 4. It's 4 comma some negative y. I don't know exactly what it is. I don't know where the turning point is, but I know it's going to be in between. This doesn't necessarily have to be the local minimum, but I know that it's going to go down. And if I wanted to, which I don't have to do on this one, but if I wanted to, I could check. Sometimes you have to check. You have to plug a number in between to see if the output's negative, which means it's below, or positive, which means it goes up. So 4 minus 3, and then 16 minus 8 minus 24. And all we're looking for is the sign. So this is a positive number. And this, let's see here. Oh, this is definitely a negative number. Oops, negative number. Positive number times a negative number. And that's, of course, a negative number. So just like we expected. So our wonderful pencil didn't let us down. Came through clutch. No cap. I hope it's been helpful. You guys have a wonderful day. Let me know if you have any questions. Until next time, you guys be safe.